Okay, so now we start recording. Okay. Then I think we can start the keynote session. Good morning, good afternoon, and good evening, ladies and gentlemen. I'm Nongwei Gu, the chair of this session. We're very happy today to have Professor Diyi Yang as the shared keynote speaker of SEM and semi-supervised. Diyi is currently an assistant professor in the School of Interactive Computing at Georgia Tech, also affiliated with the Machine Learning Center at Georgia Tech. Her research interest lies in computational social science and natural language processing. She's named among IEEE AI's 10 to watch in 2020 and Forbes 30 under 30 in science class of 2021. A very promising researcher. Recent year, we have seen many outstanding research from her. So today she's going to talk about 7 social factors in natural language processing, theory and practice. Let's welcome Diyi.
Yeah, thank you, Louis, for the great introduction. First, I apologize. I changed my title a little bit because I was told if your title is very interesting, then you will get more audience. So I changed it to 7+6. You know what I mean there. So my topics around the socially aware language technologies. So as we all know, so over the last few years, NLP has made great progress. Produced industry applications such as internet search, machine translation, automated assistance, question answering, sentiment analysis a lot. The field has moved from rule-based systems to statistical machine learning, and most recently to deep neural network. Since 2008, language models have progressed a lot in terms of model size and task performance. So we read all the news titles on translation. It's approaching human level accuracy, as well as in speech recognition and reading comprehension. So the question is, are we done solving NLP? I think the answer is obvious. Apparently not. There are a lot of challenges. So several aspects that MATLAB has been focusing on. First is around the low resource scenarios. So this includes both low resource data settings and also low resource language settings. And if we look at the real world context, they often have limited labeled data. Second, so going back to language, we use language to achieve all sorts of goals. Language use is complex and subtle, as you can see from all sorts of very interesting semantics or pragmatics phenomena. And for any given corpus or context, when we talk about reasoning or when we talk about intelligence, it goes beyond a specific corpus or benchmark. And it's really hard to organize and reason over those social interactions. So especially if we look at those two aspects, they are about the social part of language. However, current NLP systems often ignore the social part of language. We also know that natural language communication contains both content and interpersonal information. Getting the content correct is not enough. Recently, there has been a growing amount of work in our NLP community that focus on understanding the social part of language. To kind of further highlight and formalize those different social work in language and their use in NLP, we propose a set of 7 social factors in natural language processing. So this is why the 7 in my title comes from. This is basically a practical set of practical social factors that could enable NLP systems to be aware of social aspects of language. And it provides a conceptual taxonomy on a wide range of social factors in language, including speaker, receiver, social relation, context. Some of those I will talk about in the following. We build our taxonomy on top of the systemic functional linguistics and also the Gracie maxim here. one message I want to make clear is that the idea of language as a social construct itself is nothing new. Linguistics and philosophy have long modeled it since very earlier days. And as we kind of reaching a point where this idea can become implemented in system, it is a message that we could bear repeating in the NLP community. So that's where our work fits here. So the first factor here is speaker. So speaker refers to characteristics about the person who delivered the message, such as demographic attributes or some kind of changing interest here. If a model fails to consider speaker characteristics, it might result in inaccurate performance or very weird phenomena. For example, like the message from a 20-year-old German female produced by an MT system may read like it was from a 75-year-old American male. Audience here refers to, receiver here refers to audience. That is whether the text is sent to one person in a dialogue, a conversation, a broadcast, or kind of unknown audience here. The third factor here is social relation. So social relation refers to the relation between the speaker and audience, such as family, friendship, seniority. Context is basically the container or holder where language interaction happens. So it might be the domain, language, or topic. And the context here is related to Gracie maximum of quantity and relevance. Social norms refer to acceptable group conduct, common understanding, or informal rules, representing speaker and the receiver's basic knowledge of what others do and think and what they should or should not do. So language and culture are intertwined. Language reflects the society, cultural identity, and the customs, as well as communicators' values. So for example, in Japanese, the expression of hierarchy poses higher level of politeness and formality in terms of than in Western cultures. So basically the term of addressee varies in terms of social and age difference. Like junior members might address senior ones with the term of relationship compared to doing their personal names. Finally, communicative goal here cover what people want to achieve with their language use. So I'm not going to talk very detailed here. This is a very nice speaker made by my collaborator, Dirk Hovey. Overall, these 7 social factors provides a more practical conceptual taxonomy on a wider range of social factors. And my research has started to address some aspects of it, such as leveraging personalized information for better response generation in dialogue systems, recognizing humor and annoying behaviors, detecting social roles people occupy from their language interactions, analyzing how loan words work in multilingual contexts, and how people use language to exchange social support in online cancer support groups. So in today's talk, I'm going to use 3 quick examples to go through how we formulate those problems and build methods to understand the language used in social contexts. I forgot to mention that if there are any questions, feel free to either post it in the chat, although I can't see it, or unmute yourself. Okay, so let's get started. So the first part I'm going to talk about is about good faith persuasion. And it will be related to social relation and the communicative goal defined in the 7 social factors. Persuasion is everywhere. We are very familiar with it. So in this talk, we look at how persuasion works in crowdfunding context. So here we use Kiva. It's a very large peer-to-peer lending platform in US. so that we can understand how persuasion strategy people use convince others. There are also other type of persuasive contexts. For example, we pick two subreddits from Reddit to understand persuasion. So one is called the random acts of pizza. So where people can request and also give away pizza to strangers on Reddit, as you can see on the top example. There is also a widely used subreddit on Borrow Bunny. So it has a different type of persuasion in mind. So we also use it to test our persuasion models. So in total, we have those three contexts. So what makes language persuasive? Here is one advocacy message from Kiva. We know from system log that it has persuaded 3 out of 50 people to lend, but why it leads people to give? If we read this message, I'm the first lender on this woman-led group loan in Burma. This loan will be utilized to repair her old duck farm and enable her to purchase nutritious duck feed that can help boost duck egg production. This way, she will be able to support her children's education in the future. Instead of building classifier to predict whether this request is going to succeed or not, here we care more about what are the explicit semantic strategies in the language that make it persuasive. There has been a lot of work in argumentation in our field where people look at relational support structures about the claims. However, persuasion differs from argumentation since it focuses more on language cues that shape or influence our behaviors. So in this work, we utilize some existing theories, popular or more scientific. So as Kahneman said in his Nobel Prize winning book, when people are evaluating requests, there are two systems going on. System one is fast and emotional, and the people rely on superficial cues to make decisions, such as only a few left that must be very good, or expert recommended, or people who I like are doing it. System two is slower, more deliberative, and more logic. So people carefully evaluate the request and ask questions like, are those facts correct? Are the conclusions warranted? We took advantage of this line of during processing theories from psychology. So system one basically is the heuristic processing. It occurs when we don't think carefully about a message, persuaded by superficial cues. System two, systematic processing, occurs when we think deeply about a message and we are persuaded by the strengths of the arguments. So what we did here is that inspired by those theories and also data representation in our corpus, we translated them into a set of measurable language acts here. So scarcity means that when something becomes rare, we value it more. Emotion means that a message full of emotion make us care and take action. Identity is more about like social identity, whether we are from the same group, like in-group versus out-group here. Commitment means that once we did something, we would like to convince others that we did the correct thing and the others should follow. There are also concreteness, like whether the argument is solid, and impact, whether it explicitly emphasizes the impact, the vision of something that the person described in their message. So in a straightforward manner, we can annotate some amount of sentences in those advocacy messages and train classifier to predict them. However, this is a new task and time-consuming and expensive. This is true for many other social-related classification tasks or other tasks. So in this work, we want to figure out whether we can predict the persuasive acts with limited amount of data. So from a model perspective, we are interested in how to design models for semi-supervised learning with document supervision or global supervision. So explicitly, the document label here or global level is how many people get convinced by a request or whether this request succeed or not. At the sentence level, the local level, it's more about like persuasive strategies, which strategy this sentence use. So we make an assumption here that each sentence only use one strategy. We have been working on this topic for a while, and previously we used standard feature-based models. We then switched to LSTM with hierarchical structures. More recently, we designed a hierarchical weakly supervised model that can leverage partially labeled data to predict those strategies, building upon BERT. So let me explain this architecture. So at a sentence level, we basically first disentangle a sentence, the content information, disentangle the representation of the sentence into two parts. One is the content information, and another is more about the strategy information. We then can reconstruct the input text based on those two disentangled latent variables. So here the Y here refers to the strategy. For sentences with sentence level labels, we add additional cross entropy loss here. And at the document level, different from the sentence level variational autoencoder, we model the input document with sentences as a whole and assume that document level label depends on the sentence level latent variables. So depending on both the content and the strategy. So in this case, for all sentences in one document, we then can utilize LSTM to aggregate this entangled latent variable to predict the document level labels. So as I mentioned, we use three contexts here for this purpose. So random X PISA, Borrow, and also Kiva, which is a peer-to-peer learning platform. So as you can see, the three contexts are very different. Some has interest, some has no interest, and others has no direct money transaction. It's more about exchanging goods here. We collect the data here for the three contexts. So the data around the Borrow and the RAOP are public, so people can use it from our paper. We annotated the amount of sentences with different persuasion strategy here. In terms of performance, so I only show two baseline model here, so BERT, and also the semi-supervised hierarchical net from our prior work. So as we can see, the orange bar here refers to our model I just talked about. It overall outperforms BERT and the previous baseline. We also look at when we only have a limited amount of data. So when we only have 20 data points per class or 50 data points per class or 100, or what if we have thousands, what are the results will look like? So as we can see, consistently, our model is giving relatively good performance. The thing that I care more about is about how we could leverage those models to understand the semantics or understand the phenomenal content in messages around persuasion. So in one case, we look at the effects of each persuasion strategy on the persuasiveness of message. We control for a lot of confounding variable here. And we found that on Kiva, if people mentioning shared identity, such as I come from Atlanta or I come from Pittsburgh, expressing concrete details in their message help their request fulfilled. But mentioning limited amount of time, or like emphasizing urgency, does not work well for this context. If we look at a different platform, random X pizza, we found that being concrete, showing a lot of emotions and highlighting the urgency are the top 3 most important strategies to convince others to give you free pizza on Reddit. So basically, those 2 experiments show that persuasion strategies are differently effective for different contexts. It is not that one is always right or good to use. It's about using it for a proper context. In a recent work, my amazing undergrad student further look at the ordering of rhetorical persuasion strategies on success. So we found that if people ending their messages in a very polite way, and overall the use of politeness is associated with better outcomes. If we look at the different sequence of persuasion strategy, consistently rely on facts, backfires, hurting persuasion. There are more interesting patterns that we discovered. So if you are interested, feel free to check the paper. Okay, so to quickly sum up the first part, we introduced a set of persuasion strategies. We predict them through a semi-supervised framework with documented supervision. We showed that persuasion strategies differently correlated with request success. Before I move to the next part, are there any questions? Okay, I can't see the chat, so yeah, then I assume maybe no. Okay. The second part I want to talk. Okay, I saw okay. Sorry, my screen only shows my slides, so I saw someone raise their hand.
Yeah,
but
yeah. Hi, it's me. Can you hear me?
Okay. Yes.
Hey, really nice talk. I really enjoyed the first part. I have a quick question for the 3 corpus that you've collected. So actually you have someone to, well, it's all hand annotated in advance, right?
Yes.
But, oh, okay. Okay, but because there's quite a big work to do. I mean,
yeah.
Okay, but then you used, because you mentioned semi-supervised learning. So, well, you annotated at first, but then you still do it with semi-supervised and to compare the results. I might miss the part about how you did that. Thanks.
Yeah, that's a great question. So, yeah, so there are 2 layers here. So first, we did annotate a lot of data, and we want to kind of provide some usable resources for this direction as it becomes more and more important. So not only used in good faith context, but people also use it in a lot of dark patterns. So think about like ads online that persuade you to make actions influenced by language. So that's why we want to contribute a set of data sets that could facilitate any follow-up work. Having said that, so Kiva, because it's like a company provided data, so we can't share the data directly, but the first 2 data sets are public. For Kiva, researchers need to establish like a data usable use agreement with them directly. Yeah, so from that sense, the reason why we annotate a large data here is that we want to provide it as useful resources. And then when it comes to semi-supervised society, our assumption is that if we only have a limited, so yes, of course we have a lot, but imagine we only have limited. It's not only about persuasion or this specific set of strategies. There are more, such as reciprocity, social proof, and other strategies. So in the future, when people add in new data points, or when we have more categories, maybe they may not be able to afford doing a lot of the annotation, or maybe it's a context we can't get a lot of expert to do the annotation. So the modeling part is more focusing on how to address learning a new social phenomenon when we have limited amount of data. So yeah, I get the kind of relative and clear distinction that I made about the large corpus versus the semi-supervised model. So the second part is more towards whether we could make some contribution towards learning with limited data.
Okay, great. That's clear. Thank you very much.
Thank you. That's a great question. Yeah, I didn't talk about that, but we have been working on like learning with limited data using different methodologies. Okay, so I'm going to continue to the second part. So again, if you have questions, feel free to raise your hand or unmute yourself. I can't see the chat, unfortunately. Okay, the second part is about neutralizing subjectively biased statement. So we have talked about how to make language more persuasive, but what if there are some unwanted framing that we need to get rid of? I do not need to talk about this. We all know that news we read on newspapers, saw on Twitter or on other social media are kind of biased. So you can see the percentage is actually very high. Over 80% people think that the content they read on social media is biased. From a language perspective, if we look at all these kind of texts, like what I have here, left and right. One is John McCain exposed as an agent of Rothschild versus McCain accused of accepting improper donation from Rothschild. Which one is more biased? And more importantly, how can we automatically suggest less biased alternative to the same text? So this is what we want to focus here. And bias has been studied a lot those days. And what is bias? What do we mean by bias here? So in this work, we focus on framing bias and more detailedly inappropriate subjectivity. So subjective biased texts may involve subjective attitude, use presuppositions, or casting doubt. So for example, here we have framing bias, which use subjective words or phrase linked with a particular point of view. Epistemological bias here means some linguistic features that subtly modify the believability of a proposition. And the demographic bias means that there are presuppositions about the particular gender, race, or other categories. So like presupposing all programmers are male. Our goal here is that how can we remove such subjectivity bias from a sentence and to further neutralize that sentence? So for the three examples I have here, instead of pilfered from, it could be based on. Instead of will bring back, it could be which its promoters hope will bring back. His career versus their career. This is a relative new task, and we actually utilize Wikipedia to construct a corpus here. Because on Wikipedia, there is this policy called a neutral point of view that require everything there to be written in a neutral format and avoid biased language. We heavily rely on this policy to acquire our data. So to give you an example, this is a revision for an edit. So on the left, you can see this is before the change. On the right is after the change. And editors will submit a comment indicating for what purpose he or she is doing this edit. So basically, we use this edit comment as a label to determine whether this change is for neutral point of view or not. Utilizing that neutral point of view policy on Wikipedia, we then construct a parallel corpus of biased language with over 180,000 sentence pairs. So here are some quick examples. On the left, we see the text with subjective bias. On the right, it's a corresponding neutral point of view. So we can see that the author's expose on nutrition studies versus the author's statements on nutrition studies, etc. It's worth mentioning that, so although we contribute this large corpus, there are still a lot of follow-up work to be done. For example, from a multilingual perspective, as Wikipedia has all sorts of language versions. In the following, I'm going to focus on one specific data portion of this corpus that is only about this single word change. Building our corpus, we introduced the two baseline here. The first one is what we call concurrent. So it's a very standard sequence-to-sequence neural network. We use BERT as the encoder here to process the input text, and the decoder is attentional LSTM. We also did a pre-training on the, we pre-trained the decoder as a language model of neutral text. So doing this will enable us to have a very nice data-driven prior of how targeted language should read like. We also add a token-weighted loss here to better model the neutralization process. The intuition is that the source and the target should have a high degree of lexicon similarity, but the goal is to learn the structure of their difference. Otherwise, all the neural models will only copy the input to the output. So we do not want such a simple copy to happen. So we kind of penalize the direct copy and the reward change in this domain. The second model is more like a simulation, like simulate how human read a sentence. So what I mean by simulation, so to do this, we introduce a tagger here in addition to the regular encoder. So this tagger will predict possibly biased word. That is, for each word here, we predict how likely this word is going to be biased. And then we can concatenate, combine this prediction and the encoder representation into a joint embedding. And we then can decode that as normal and apply all the techniques I mentioned earlier. So why we want to have two types of models? Yes, we have two because one is relatively end-to-end. So there is no much interpretation in the process. So you can train it. The second one kind of incorporate the human insights. So it's less end-to-end, but it's more interpretable. If we look at the final predictions in terms of which word is biased and how you could control the joint embedding there. In terms of evaluation, we train on Wikipedia corpus, test on Wikipedia, and compare to a lot of state-of-art methods for generation. And we evaluate, in addition to BLEU and accuracy, we also look at fluency, meaning, and the bias. We provide a rigorous training to our annotators in terms of how to recognize something is biased based on the neutral point of view policy. So as we can see here, so modular or the concurrent model, the message is that there is no clear winner. And also that's why we have two models here. The modular does a better job at reducing bias. So this is simulating human insights, where the concurrent appear to better preserve the meaning and the fluency. We did a lot of interesting generalization of the model. For example, what if we apply the model trained on Wikipedia to different domains, such as political books or news headlines or campaign speeches? So we can see there are very interesting modification here. On political books data set, the original framing is activists have filed a lawsuit versus critics of it, or critics. News headline like Zuckerberg claims Facebook can versus Zuckerberg stated Facebook can or says Facebook can, etc. So amazing Americans reduced to Americans. So this is around like neutralizing bias. I guess in addition to like more models to make the number higher, what can we do with those results? And or people can use them in like social scenarios. So in one of the recent work, we actually built an interactive system to enable users to rewrite their message with the help of a tool. I don't have a demo today, but we will have it in 1 month. So basically, when people input a text here, based on our like either bias detector, or here we use hate speech as one scenario, we highlight which words are kind of more influential to the final prediction, and we highlight those to users. We also generate a potential alternative wording to use for this kind of context. We did some user studies to test how useful is this tool. We found that when our model system recast is enabled, you can see the toxicity prediction. It's much lower compared to when people do not use recast. So this is a very nice visualization system built upon the kind of NLP models we built. Having said that, there are still a lot of challenges whenever it goes to either biases or hate speech. So when it involves multimodal, or when it involves implicit, like more like implication of language. So that's all about the second part. Any further question here? Okay, if not, I can move to the last part, and then we can do a discussion after the talk. So the third part, I want to talk about something I'm very passionate these days, also related to communicative goals. That is how to summarize our daily dialogue or daily conversations. We are all very familiar with all sorts of like chats or text messages these days because of pandemic. So sometimes if you are away from your laptop, once you are back, you will see there are a lot of chats in Slack or forum. It's really hard to catch up. So the goal here is how could we process and organize interactions into some concise and structured data? One possible solution is, can we generate a obstructive dialogue summary for a given dialogue? This task is a little bit challenging compared to regular document summarization, because in these informal dialogues, they are informal, and there may be like repetitions, hesitations, interruptions, and then the important information is kind of scattered in the whole chat, making the current summarization models harder to focus. Despite the less structured features of dialogues, there are still several patterns we often use to understand the conversations. So for instance, from a classic perspective, we can just treat the conversation as a whole and do what we did for document summarization to this domain. Or we could treat it as a discrete view that each sentence is a unit for our representation. Our work, we propose that most structures from conversations can be used to represent the conversation better. So then we can use it to help conversation summarization. The first is around the topic view. So one single conversation may cover multiple topics. We also introduce stage view, that is, conversation develop certain patterns as they progress. So we may see patterns like introduction, or there are stages where we wrap up. We then extract those structured views in an unsupervised way, as we don't have any annotated label for those different views. To get the representation, we first represent each utterance into a latent representation. For topic view, we use topic segmentation model here to segment the conversation into different topic segments. So here we choose the algorithm C99, which basically calculates the similarity between adjacent utterance in a window to split the conversation. For stage view, we train a hidden Markov model here, where the hidden states are stages and then the observations are representations. So in this case, we can predict the specific stage of different utterance. After that, a conversation that we saw earlier can be broken into different blocks if we use topic view, or if we use stage view, they are converted into different blocks. We then design a multi-view sequence-to-sequence model to kind of leverage those different blocks. So specifically in the conversation encoder part is where we deal with our different view. Instead of using each utterance here, so our unit is each block. For each view, we can get the view level encoding by aggregating each block's representation. So in the decoding process, it's basically similar to the general transformer decoder. Specifically, we introduce a multi-view attention layer in each transformer block. It decides the importance of each view. And then based on the importance of each view, we do all the following learning. We perform experiments on a recent human annotated data set called Samsung. So it's a daily conversation data set. So you can see several key information here. So usually it's about 2 people, but in some cases it's about 3 or 4 people, and it's relative long. And compared to baselines, you can see that our multi-view BART or model that leverage stage or topic segments are outperforming like either the global view or use discrete view here. Again, we want to understand the why and how to further improve the dialogue summarization model. To do this, we've manually analyzed the challenge. We manually analyze around 100 conversations to see what are some consistent or like obvious challenges here. And we summarize certain aspects. The first one is around informal language use. So in our chats, we saw that there are abbreviations, typos, slang, or emojis, making it hard to represent and summarize conversations. There are multiple participants. Their information sometimes conflict with each other. There are multiple turns, a lot of repeated turns, require the model to keep track of turn switching. There are also referral and co-reference. People refer to each other, mention others' name, and use co-reference in their messages. There are repetition and interruption. So people interrupt each other, maybe back channel or repeat themselves. This is a very unique discourse challenge for dialogue summarization. There are also negation. This is a long-standing problem in NLP. There are also like a role and a language change. A person may shift from a questioner to a person who answers questions, requiring the summarization model to dynamically deal with speaker role. Those are the set of challenges we summarize for conversation summarization. And we further look at for the best performing model so far, are they doing well, or which aspects they fail for those different challenges. So we saw that models' performance are worst when it comes to referral, co-reference, coming to repetition, interruption, and also multiple turns. So these are some of the big challenges that are relatively easier to solve, but very important for current models. We further look at how we could address those three aspects by looking at the discourse relations between different authors. So if we could model the relation between different authors, that may give the model more faithfulness. We also look at who did what kind of triplets from authors. This can provide explicit visualization of speaker and their actions. Because one thing we observe in the generated summary is that like it always assigns the wrong object to the wrong action. We then like improve our model to kind of leverage those two aspects, discourse graph and action graph. As I show here, when we incorporate both discourse and action graph, it's giving much better performance. And this improvement is also significant when we generalize the model to some out-of-domain dialogue data sets. So as we can see, the performance compared to BART-based is almost doubled. I forgot to mention this, but every generation we did, we also evaluate them with human annotators and obtain the consistent results. We made all the resources available on our GitHub so people can check them out. I also want to mention and shout out to the summarization dialogue summarization special session happened at the Citadel last week, where they present a lot of very interesting work around the dialogue summarization. And of course, there are challenges around how to deal with multimodal citing, and is there only one summary for one dialogue, etc. So that's about my work today. And to kind of sum up, I introduced the 7 factors for social NLP. And this is a practical taxonomy. You may wonder where is the 6th. So looking ahead, so 6 questions that I think social NLP could think carefully and in order to push our field to the next level. I also hope that this could stimulate discussion, inspire follow-up work into social NLP. So the first is around is theory necessary in the age of data. So we have a lot of nice theories. What's the relation between data and the theory? Can we improve theory from data? Can we better model data utilizing theory? We are familiar with benchmark, but a single corpus may not be able to include and represent the dynamic scenario associated with a social phenomenon in terms of size, genre, or population. Should we use benchmark, or what are the right way to go here? Should the social NLP passively learn the world? Right now, everything was done at a passive fashion. So we only look at what is in the data and learn from it. That limits how we can adapt to new scenarios, even with simpler tasks. Should the model and the evaluation stay the same? For example, for the dialogue summarization, we compare with one ground truth summary, but is that a summary the only way to go? Kind of change when the user changes. Like if I want to only know a specific aspect. And there are many subtle nuances about the social phenomena. So sometimes there may be no ground truth, or sometimes every answer can be correct in a certain scenario. This is a common challenge we face right now, how NLP or how social NLP can be responsible and reproducible, especially when they involve like a user data or social phenomena. How we could share data in appropriate and ethical ways is very important. The last question is, does social NLP speak English? So two aspects here. First is that language dialects and the culture behind our problems, models largely influence the comprehension of social NLP. And with NLP being applied to everyday interaction, we want to make sure that it can work for different contexts and without assuming all conversations follow Western culture and the norms. That's about my talk, and I would like to conclude it. Thank you so much, and I'm happy to take any question here or discuss about this 7 plus 6. Thank you. How I could see the chats, or is there?
Okay, so thanks for the great talk. Any questions here?
Yeah, maybe
No
my talk is very persuasive, so.
Yeah, very clear.
No, thanks.
No question, and I have one question.
Oh, I saw Bill.
Oh, you have questions?
Yeah.
Okay, cool.
Hi, thanks. Yeah. So my question is about the functional linguistics taxonomy. So I'm interested, I mean, maybe it's a bit vague at the moment, but there are works in semantics that try to, or in distributional semantics that try to separate sort of semantic from syntactic information in say word embeddings, for example. And I'm interested if you think that something like the SFS taxonomy you could do a similar thing where you try to represent different aspects of the social meaning of words with, say, different parts of a distributional representation. And then also, I mean, just more broadly, is it possible to separate social meaning from sort of more classical truth theoretic or classical meaning?
Yeah. Thanks. Thank you, Bill. I think this is a fantastic question. So first, our taxonomy is built upon the systemic functional linguistics. So systemic linguistics, SFL, has 3 kind of meta functions. So one is text grammar. So it's more about like syntactic rules of how to organize words into sentences. There are other 2 dimensions. One is like interpersonal semantics, so more about like social relation, etc. There is 3rd dimension is ideational semantics. It's more about like the experience in which the language is used, etc. So yeah, so we kind of use that to inspire the taxonomy. And then coming back to the question of whether we will be able to have a separate, or should we separate the representation from the content and the social? I think this is very cool. And we have been thinking about how to, let's say, convert the representation that we have, let's say, word embedding or other representations into a set of structured dimensions, like what we mentioned here. So can we convert a vector into 7 factor here? And is this 7 factor enough? Are there anything else? So I would say this is some of our ongoing investigation. We don't have a perfect answer yet, as it's not easy to separate. I mean, we can, of course, do disentanglement to make sure, okay, this space, this representation is very relevant to social factors. This is very relevant to some syntactics. If we could enumerate all the dimensions we have, social factors, and also the syntactic rules, word orders, etc. We can of course do that, but it's also not clear whether we have the complete set of such list. But this is something like we are doing right now. So we hope that we can share more with the community in terms of, can we find some specific region or subspace aligned with specific social factor we mentioned here. And I really like your question. I don't have an answer, but this is a great next step that we all should work towards. Maybe there is a separation.
Okay, cool. I look forward to seeing that. Yeah.
Thank you. Cool. Ted, I saw there are two. I don't know which one first.
Hi, can I ask a question? Or?
Yeah, sure.
All right. So yeah, it's a really nice presentation and really interesting work. But since you are working on this social NLP and the social data, my question would be, are you considering multimodal data? Because now the social data are in form of memes, in form of images, and many other things. So are you incorporating those image data as well? Maybe some smileys, GIFs, all those things are part of this SMS or the chats.
Yeah, again, very cool idea, and I think we should. So let me give you some basic statistics. So far, like if we look at a lot of the work in computational social science or like social NLP, a lot of times we have been focusing on English. So, but there are also work look at a multilingual interpretation of words or phenomena. So for example, politeness is such an example. In Western cultures, politeness is rendered or like manifested in a different way if we look at politeness in other culture contexts. So there has been some great work there. Another is that we have been working on mental health, like depression. You saw different language usage from Asian countries versus Western countries in terms of depression markers in language. So incorporating different culture and in multilingual context definitely will add a very rich signal to social NLP. And then in terms of multimodal, I think that's a greater way to facilitate collaboration between vision and speech and also the language community. So for example, if we are in a room right now and when we are talking to each other, we look at each other, there might be gestures, there might be something that maybe I didn't see, but you can signal it from my gestures or impressions or whatever. So those are very important signals. And in certain very high stakeholder cases, for example, people who might have difficulty in using language, those rich multimodal signals will be very useful. And I also want to shout out to one recent paper from our community where when people are looking at hate speech, they use memes because in many cases, the picture plus the language create a hateful image there. So this is great direction, and I think we should move towards that if people are interested in the future.
Thank you.
Thank you. I guess I don't know what's the order, so feel free to unmute yourself.
Hi, this is Dikshita.
Hi,
I hope I'm audible. It's a really great presentation and a lot of different streams that you have covered here. So I would like to know one thing about generalizability. So because I have like 4 to 5 years of experience in industry where I've seen a lot of places where state-of-the-art models do not perform well when it comes to domain specific tasks. Like it's not easily generalizable to the domain specific data. So, and there's one more problem of less annotated data as well. So what are your views on that? And how do we have to move towards creating generalizable models or any evaluation metrics that look at generalizability?
Yeah, I think a great question, very, very important for a lot of the models. So again, there are multiple aspects to this question. For example, like in a lot of the cases, I think the phenomena, especially in social NLP, it might be tied specific to a context. So as I went through my work on persuasion, we saw that in different contexts, it's working differently. And that's one way to kind of show generalization. So when you train the models in other in one domain, maybe generalize it to other domain to see how well it performs. And that may inspire new methods. And as we also show on the like subjectivity bias. So when we train on Wikipedia, we also applied it to multiple other domains to see whether they actually work. In dialogue summarization, we generalize it to a different dialogue context to see whether it works. So from a method perspective, I think this also pose challenge in like how we could do better transfer learning, how we could make sure models can learn in a continual fashion, like continue learning, how to make sure it's happening there. This also pose challenges to data and the resource. So for example, like a lot of our tasks right now, there may be a need to have more kind of challenge set or generalization set, etc. So I think maybe like a unified framework testing the generalization in terms of method, in terms of data, task, challenge set will be very helpful. And yeah, I think from researchers, what we can do, if you are working on very specific task, you want to demonstrate generalization ability, I encourage like maybe explore more with reliability test, like the paper presented at ACL this year, and also generalize it to out of domain to see whether performance are consistent. Thank you.
Thank you so much.
Okay, maybe we will take the one last question. It's almost time. Anyone? Please just unmute yourself.
I was just going to ask about your section on toxicity. That was very interesting. So have you got a separate paper on that, or was that all part of the same paper that you have written? So I could delve into it a bit.
Oh yeah, this is a different paper. So you can see the link here. It's also on my website. This is like a visualization system. We didn't have new NLP algorithm here, but we want to see whether we could build an app that the people could play around if it's stacked with, let's say, a bird classifier or any classifier. In this case, we may be able to have a broader plug-in. So when people are writing on social media or writing online, similar to like a Grammarly, but more in terms of paying attention to words that may create hateful interpretation or may be biased or may be ill intention. Yeah, so that's the goal here. So it's not like a typical NLP paper, but more in terms of how we build a system to do that. And I really like the user studies we did. One very cool takeaway is that people game with the system. So because we are giving them suggestions and they have a way to tell whether something is toxic or not, they will use more sophisticated expressions to still express hateful meaning, but bypass our model. So I think this is also something very interesting for our hate speech detection community. Like when people are use like coded language or use like this type of like a sophisticated level, all our models fail. So
yeah, that's fantastic. I really enjoyed this too. So if I want to read a bit more on these, both of these PowerPoints, that's the paper to look into, is it?
Yeah, exactly. So it's here. So on the bottom.
Got it. That was really good. I really enjoyed that. Thank you so much.
Thank you.
Okay, it's about time. Maybe you still have some questions. I think you can talk to Diyi offline. So let's thank Diyi for her great talk again. And here I have one thing to say, that please take a look at the message box because the underline put the SEM eval and star SEM link, like confusing links on the web page. So please, the star SEM participants, stay here in this room and look at the message box. There's a SEM eval link here. You can, if you're participants of SEM eval, you can link back from this Zoom link. Okay, Diyi, thanks again for your great talk. I think I'm going to give the floor to our next session chair.
Thank you.
Yeah, so thanks a lot for the talk once again. And we'll be starting in 25 minutes with the third and final session of today. So we'll have the standard format with lightning talks and posters. So see you in 24 minutes. The same link.
Okay.